What is the Shapiro Wilk test for QQ plot? Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intudo4U has them all. It's like having a research dream team on demand.
All right, let's dive in. Today, we're going to be detectives. We're putting on our hats and investigating a single, really crucial question about our data.
You know, every data set tells a story, right? But here's the thing. Sometimes that story can be, well, a little deceptive. Our job as the detectives here is to figure out, is our data playing it straight with us, or is it hiding something important?
Because here's the deal. In statistics, we've got all these super powerful tools, right? But they all operate on this one big assumption. They just assume your data follows that classic pattern. You know the one, the bell curve, the normal distribution. And if that assumption is wrong, whoa, any conclusions you make could be totally off base. So why does normal even matter? I mean, really, what's the big deal? Well, it's because a ton of the statistical tools we rely on, let's call them our key witnesses in this investigation, they absolutely depend on it.
I'm talking about the big ones, the tests you've probably even used yourself. T-tests, ANOVA, linear regression, they all need that normal distribution. If you use them on data that isn't normal, it's kind of like building a skyscraper on quicksand. The whole thing could just collapse. Your results, totally unreliable.
Okay, so any good detective knows where to start, right? You get to the scene and you just look around. Before we pull out any of the fancy gear, let's just use our eyes. What are the first clues we can spot just by looking?
The most basic clue is a histogram. Super simple. If your data is normal, you get that perfect, beautiful, symmetrical bell shape you see right there on the left. But if your data looks more like the one on the right, all piled up on one side, that's a huge red flag. That's our first sign that something's not quite right here.
So a histogram is great for a first glance. It gives you the general vibe. But if we want to get more precise, we gotta bring in a special tool. It's called a quantile plot, or just a QQ plot. This is like dusting the scene for fingerprints.
And the great thing about the QQ plot is how simple it is to read. Seriously, all it does is compare our data points to where they should be in a perfectly normal world. And if our data is normal, bam, the dots just line up perfectly on that straight line. It's that easy. Straight line, we're good. Crooked line, Houston, we have a problem.
Okay, looking for clues is one thing, but in a really serious investigation, you can't just rely on what you see. You need to call in an expert witness, right? Someone who can give you a cold, hard, objective number. And for this job, our expert witness is the Shapiro Wilk test.
So, to get how this test works, picture this. We're in a courtroom. Our data is sitting there in the defendant's chair. And what's the charge? Not being normal.
Now this is super important. Just like in a real court, our data is presumed innocent. The starting point, which we call the null hypothesis, is that the data is normal. The test's whole job is to try and find enough evidence to prove it guilty of being non-normal.
And the verdict? It all comes down to one single number, the p-value. Just think of 0.05 as our legal standard, beyond a reasonable doubt. So if that p-value is bigger than 0.05, we say, not enough evidence. We fail to reject the null hypothesis. The data is not guilty. It looks normal. But if the p-value is less than or equal to 0.05, guilty. We reject the null. We have enough evidence to say the data is not normal.
All right, so we've got our visual inspection, we've got our expert witness. This should be an open and shut case, right? Well, this is where our detective story gets a major plot twist. Let's open up a real case file.
Check this out. Here's the case with 348 data points. Take a look at that QQ plot. I mean, come on, that is a beautiful straight line. Our eyes are screaming at us. This data is perfectly normal. It's a model citizen. So, case closed. Let's go home, right?
Hold on, not so fast. We call our expert witness the Shapiro Wilk test to the stand, and it drops a bombshell. The p-value? 0.0049. That is way, way below our cutoff of 0.05.
So now, we've got a problem. A real paradox. Our eyes are telling us one thing. It's normal. But our expert witness is screaming the complete opposite. So who do you believe? Your own eyes or the cold, hard number?
Okay, how do we crack this case? To solve this mystery, we've got to do a background check on our own expert witness. It turns out the Shapiro Wilk test has one peculiar little weakness.
And this quote right here from a bunch of statisticians talking shop, it hits the nail on the head. See, the problem isn't that the test is wrong, it's that it can be, well, too right.
Here's the big reveal. The Shapiro Wilk test is incredibly powerful. It's like a superhero with super hearing. And when you give it a large sample size, and for this test, anything over 50 or so can be considered large, it becomes almost too sensitive. It starts picking up on these tiny, microscopic little wobbles away from a perfect bell curve. Deviations that are, yeah, technically there, but in the real world, They don't matter at all.
So, you see, our two pieces of evidence aren't actually fighting each other. They're telling us two parts of the same story. The QQ plot, our visual inspection, gives us the big picture, the spirit of the law, you could say. The Shapiro Wilk test gives us the letter of the law, the absolute mathematical truth. The catch is that with lots of data, the letter of the law can be just a little too picky for its own good.
So, what's the takeaway? What's the procedure for a good data detective? It's simple, just 3 steps. 1. Always visualize first. Always. Start with a QQ plot and see what your eyes tell you. 2. Then run the Shapiro Wilk test to get that objective number. But 3, and this is the most important part, put it all in context. Think about your sample size. If you've got a ton of data and the QQ plot looks good, you should probably trust your eyes more than that tiny p-value. But if your sample is small, that test's verdict becomes way more reliable.
So in the end, the Shapiro Wilk test isn't broken. It's just a really powerful tool that was designed for one world and now lives in the age of big data. And the lesson from this whole detective story is a really big one. As our tests and our computers get more and more powerful, more and more sensitive, our human judgment, our ability to step back and see the whole picture, that becomes more critical than ever before.
And subscribe now for more amazing videos just like that. Thanks for watching.